Okay, so we've covered what JavaScript is and where it runs. Now it's time to tackle a really fundamental question. How does it actually remember things? You see, every single program needs a way to store and manage information, and in JavaScript, that's where variables come in.
But let's start with a bit of a weird question, just to see what happens. What if you just used a variable without ever properly creating it first? It sounds like a simple mistake, but the answer really gets to the heart of why modern JavaScript works the way it does.
So you write something like this. You don't use var, let, or const. You just make up a name and assign a value. You probably think you're just creating a variable on the fly, right? Well, you're actually setting a trap. JavaScript does something totally unexpected here, and it's the kind of thing that can quietly break your entire app.
See, instead of creating a nice, contained local variable, JavaScript goes on a hunt. And when it can't find a variable with that name anywhere, it goes all the way to the top, to the global window object in your browser, and just slaps your variable right onto it. Think of the window object as the master control panel for the entire web page.
And yeah, this is a huge problem. We call this polluting the global scope. You could accidentally overwrite a critical browser function, like scrollx, and totally break the page's scrolling. Or worse, you could have a name collision with some other library you're using. Your code suddenly becomes this unpredictable mess that's a nightmare to debug.
So how do we avoid this disaster? Well, thankfully, modern JavaScript gives us very specific, very precise tools to declare what we want to do and to keep our variables safe and predictable.
The best way I've found to think about this is to imagine variables are just labeled boxes. Simple, right? You put information inside them. But the keywords we use to create these boxes, well, they set the rules for how those boxes behave, how big they are, if you can change what's inside, and where they're allowed to exist.
JavaScript gives us three key words to make these boxes. First, there's var. It's the original way, but it's now considered legacy code. Then you have the modern standards, let for variables whose values might need to change, and const for values that are meant to stay put.
This table really breaks down the critical differences. Let's look at the scope column. Notice how var is function scoped? That's a pretty big, loose container. But let and const are block scoped, which means they only exist inside the nearest set of curly braces. That gives us way more control. Now look at Redeclare and Reassign. The fact that var lets you do both is actually a huge source of bugs. Let and const are much stricter, which leads to more predictable code. And that's exactly why they're the standard now.
Oh, and a quick but super important point about const. It doesn't mean the value inside the box is frozen. It means the assignment is constant. The label is glued to that one specific box. So, if you put an object or an array in a const box, you can't swap it out for a different one, but you can absolutely change the stuff inside that object or array.
Okay, let's dive into one of JavaScript's most unique behaviors. It's called hoisting. It's this weird behind-the-scenes thing the engine does to prepare memory before it even starts running your code.
So what's happening is the JavaScript interpreter does a quick first pass over your code. And as it goes, it finds all your variable and function declarations and kind of just moves them to the top of their scope. It's like it's setting up all the empty labeled boxes before it starts the real work.
And this example shows you exactly why this matters. With var, the declaration gets hoisted and it gets initialized with a value of undefined. This means you can use it before its line in the code without an error, which can hide some really nasty bugs. But with let and const, they get hoisted, but they're not initialized. So if you try to access them early, you get a big, clear reference error. It's actually much safer.
This state, where a variable is hoisted but not yet ready, has a name, the temporal dead zone, or TDZ for short. It's that tiny window of time from when you enter a scope to the exact line where the let or const variable is declared. This isn't a bug, it's a safety feature. It's designed to stop you from using a variable before it has a proper value.
Let's move on to scope and see how all this ties together. Hoisting are keywords. They all operate within the rules of scope. And scope is simply the system that determines where your variables live and who has permission to see them.
In JavaScript, we've got three main scopes. There's the global scope, the outermost level, anything here is visible from anywhere. Then there's function scope, which gets created every time you make a function. This is var's natural habitat. And finally, you have block scope, which is created by any pair of curly braces, like an if statement or a loop. This is the tighter, more contained world where a let and const live.
So, what's the crucial takeaway here? It's this simple but powerful rule.
A child scope can see variables from its parent scope, but a parent scope can never see variables that were created inside one of its child scopes. Information flows down, never up.
This code shows that rule in action perfectly. The let and const variables are literally trapped inside the if block's curly braces. If you try to use block let outside of it, like in that commented out line, you get a reference error. But look at function var. Because var only cares about the whole function, it completely ignores the if block. This is exactly why block scope keeps our code so much safer and cleaner.
All right, so we know how to declare variables and we know where they live. Let's quickly touch on a professional habit, how to name them. Because good naming can make your code so much easier for you and others to understand.
We can just follow some simple, effective rules from industry-style guides like Google's. Use lower camel case for your typical variables. For values that are truly constant and hard-coded, use all uppercase with underscores. And the most important rule of all, just choose names that actually describe the data they hold.
The reason this is so important is that clear naming makes your code self-documenting. Someone else, or let's be honest, you in 6 months, should be able to read a variable name and immediately get its purpose without needing to hunt down a comment to explain it.
So, we've learned how to create the boxes. We know the rules for those boxes, and we know where they live. That brings us to the next logical step on our journey.
Now that you know how to declare and manage variables, it's time to explore what you can actually store inside them. We're talking about the fundamental data types, things like strings, numbers, and booleans, that are the real building blocks of every single JavaScript program.
And to leave you with a little something to think about, we know var is function scoped and completely ignores blocks. So, what kind of weird, unexpected behavior do you think you'd get if you used var to declare a counter inside a classic for loop? It's a very famous JavaScript pitfall.
This is Developer Roadmaps. Map your path, build your career.